Hi guys, let us discuss about the uninformed search. Generally, so many numbers call this as uniform search, but it is not a uniform search, it is called as uninformed search. In this session, we discuss several strategies or methods that are classified into category that is called as uninformed search methods are also called as blind search methods. These strategies have no additional information about states beyond that is what provided in the problem definition. So they are called as blind search methods. All they can do is generate successes and distinguish a goal state from a non-goal state. All such strategies are distinguished by the order in which nodes are expanded. Searching solutions. Solution is an action sequence from the search algorithms. This can be implemented using search tree. Search tree. Generally, search tree means we will start from root node to and goal node and the possible action sequences starting at the initial state from search tree with the initial state at the root. The branches or actions and the nodes correspond to states in the state space of the problem. Searching here, we are searching a array from the root node. We are going array to CBU and CBU to array. We are generally searching array from the root node. Representing the nodes. Here state. State means a state belongs to a state space and node belongs to a state. Parent. It generates the child nodes. Action. The action executed while in parent node to generate the child nodes. Path cost. The cost from node to node is called as path cost. Depth. The number of steps along the path from the initial state is called as depth. Distinguish between node and state. A node is a bookkeeping data structure used to represent a search tree. A state corresponds to a configuration of the world. Nodes are on parts but not the state. The state can be reached through two different nodes. Nodes are data structures from which the search tree is constructed. Each has a parent, a state, and various bookkeeping fields. Let us discuss about the uninformed search algorithm. Uninformed search is a class of general purpose search algorithms which operates in a brute force way. Brute force way means step by step way. Uninformed search algorithms do not have additional information. So it is called as blind search algorithms. As it do not contain additional information, we also call as uninformed search as a blind search. There are types of uninformed search algorithm. First one is breadth first search, depth first search, depth limited search, iterative deepening depth first search, uniform cast search, bidirectional search. Let us go to breadth first search. Breadth first search is the most common search strategy for traversing a tree or a graph. This algorithm searches breadth-wise, so it is called as a breadth first search. BFS generally starts from the root node and expands all the successor nodes at the current level before going to the next level. Means first it go to the root node, start from the root node, and visit all the successor nodes at that current level before going to the next node. If the goal node is successfully found in that current level, you stop the process there itself. The best first search algorithm is an example of general purpose search algorithm. Breadth first search is implemented using FIFO-Q data structure. Let us discuss about the advantages and disadvantages of breadth first search. BFS will provide a solution if any solution exists. If there are more than one solution, for a given problem, then BFS will provide the minimal solution which requires the least number of steps. Disadvantages. It requires lot of memory and it needs lots of time because it want to check all the successor nodes from at that current level. Let us discuss best first search using an example. Let's start from the root node and here goal is k. So we have to start from the root node and go to the k. First, the process is start from the root node and check all the successes at the next level. There are no successes in S, so next level A and B. We'll search A and B. Still we are not reached to the goal. Then again go to the next level and check all the successes in the next level. C, D, G, H. We do not find our goal. So again go to the next level. E, F, I. Still we didn't find our goal. Then again go to the next level. We find out the goal. Stop the process here. Like this, we will use bed first search. Let us discuss about the time complexity of the best first search. Time complexity of best first search is generally omega of b power d, where d is the depth of the shallowest solution. B is a node at every state. Here, time complexity and space complexities are both are equal. That is omega b power d. Completeness. BFS is complete, which means if the shallowest goal node is at some finest depth. Optimality. BF is optimal. It gives the least cost path. So it is very optimal solution. Let us discuss about depth first search. Depth first search is a recursive algorithm for traversing a tree or a graph data structure. It is called depth first search because it starts from the root node and follows each path to its greatest depth node before moving to the next path. Means it starts from the root node and follows each path to its greatest depth. Means greatest depth it will go before moving to the next path. DFS uses a stack data structure. Generally, the process of DFS and BFS are both are similar, but there is only is backtracking is available in DFS. Backtracking is an algorithm technique for finding all possible solutions using recursion. Let us discuss about advantages and disadvantages of depth first search. Advantages. DFS requires very less memory and less time. Disadvantages. There is a possibility that many states keep on recurring and there is no guarantee of finding the solution. DFS algorithms goes for a deep down searching and sometimes it may go to the infinite loop. Some disadvantages are there. Let us discuss the depth first search using an example. Here root is S and goal is G. We have to start from the S and go to the next level A. Will go greatest depth from S in the path of A. Means S to A to B, B to D. Still we do not reach our goal. So backtrack means D to B. But B already visited now. There is no use that is going D to B. So directly we go to D to E. And similarly E to C without going E to B, B to A to C, we directly go to the C. And again C to greatest depth G. We reached our goal. This is how depth of search is implemented. Let us discuss about the completeness of the depth first search. DFS search algorithm is complete within the finite state space as it will expand every node within a limited search tree. Time complexity is omega of n power m, where n is the number of nodes, m is the maximum depth of any node. And space complexity is the omega of b power m, optimality of the DFS. we are actually do not consider it as optimal solution because it may generate large number of steps or high cost to reach the goal node. Let us discuss about uniform search tree directly with an example. Here, the process of the uniform search tree is we start from the root node and go to the goal node in a way in a way that which has the path which path has the least cost means we will select a path which has the least cost means here from S there are two paths A and B but here the least cost is 1 so we will go to A and from A there are two paths 3 and 2 we will directly go to the A to D which because it has least cost than A to C. Then again D to C, G as it is a goal node will directly go to the G. This is how uniform cost search tree is used. Next, iterative deepening depth first search. It is equal to the DFS, but only here difference is will go to the depth, but only successors depth. Means let us discuss explaining. This is root node and this is goal node. We'll first check root node. No, we not reached the goal. Then again, next level, all the nodes we are visiting the next level depth means A to B, B to C. Still we do not find. So again we increase one level of the depth means A to B, B to D, D to E and backtracking E to C, C to F, F to G. And again we will increase one level A to B, B to D, D to H, H to I to E to C, F, K, G. In fourth iteration, the algorithm will find the goal node. Here see A, B, D, H, I, C, F, K, J. It is not used as optimal solution because it has the highest path and highest cost. So we do not consider it is an optimal. Let's go to the another example. Another type of the uninformed search algorithms that is called as bidirectional search. In this bidirectional search, will the T diagram is divided into two parts by the intersection node. Here 9 is the intersection node and left part of the intersection node is forward search and right part of the intersection node will perform the backtrack search. Here we will go from 1 to 9, we'll select a path and from 16 to 9 we will select a path. Here right it is backtracking and left side is forward search. By combining both paths we'll get a path which has which will reach the goal node from the root node. Means here from 1 to 9 we will select a path 1 and 16 to 9 we will select one path. By combining the both paths we will get a path which has path of least cost from 1 to 16 which is root node to goal node. This is how bidirectional search is done. Thank you.